Good morning, everyone, and welcome to today's webinar about what's new in Solid Edge 2024 Part 2. The agenda for this webinar is we will discuss all the new enhancements and features that have been added to the 2024 version. We have some physical thread enhancements, some new commands such as saved as mirrored part, trim tubes. We can now see AI enabled in your replace part command. We have some enhancements for the assembly search, an option to remove the disjoint bodies using the subtract command. We have some options to reorder the assembly features and suppress the conflicting relationships. So let's take a look at all of these commands one by one. So firstly, we have the option to add clearance in the physical threads. So this clearance can be added in the form of percentage or an absolute value. This clearance value can be used in your holes as well as your threads. Next, we have a new command that is called as save as a mirrored part. So this new command, as the name suggests, will create a copy of the original part, which is a mirrored version of the original part. Now, this copy can be created in two different formats by linking to the original model and by removing that link. And we have a new command that is called as trim tubes, and this command is an assembly feature, so you have the option to add this as an assembly feature, or you can have this as an assembly driven part feature. So the workflow for this is very easy, where you simply first select your primary tube and then select all the intersecting tubes with your primary tube, so that the software or this command will create a cut as you would expect. So now let's take a look at all of these commands in action. So in this example, we'll take a look at the physical thread enhancement that has been added. So to take a look at that enhancement, first what we can do is we can go to this thread1 command, and once you go to the edit definition, under the physical thread dropdown, you have the option to add clearance. So right now, before I add clearance, as you can see that both the threads have a very tight fit. Now we can simply add the clearance in the form of percentage or absolute value. So let's take a look at the percent value first. So now I'll give it a percentage of 5, and once I give that percentage, you can hit finish, and a clearance has been applied on the thread 1 part. Something similar can be done on holes as well. So we'll go back to holes and go to edit definition, and inside the edit definition, now you can, instead of using percentage, let's take a look at the absolute value. So here we can give it a value of 0.2 mm, and it creates that clearance. So now, as you can see, as compared to the previous one, we have added clearance for both your thread as well as the hole inside the part. So this was the new enhancement in which you can add clearance on both the threads as well as holes. Next, we'll take a look at the save as mirrored part. So right now, as you can see, we are in the part environment, or in this case, we are in the sheet metal environment. Now to create a mirrored copy, you'll have to come to the mirror drop down and select this option that says save as mirrored part. Now, like I said, we have two different options. First, when you create a link to the original, it creates a part copy. So let's take a look at that. I'll select this plain one, and once I select the plain one, it automatically gives me an option to create the part copy. So I'll just give this part a name that says mirror 1, and once I create that mirror 1, you'll see that I get a part that is a copied version of the previous one. And as you can see, under the history tree, all you have is a linked part copy, so you don't get any of the history of the part. Now, if you were to make any change to the original part, these changes will be reflected in this mirrored part as well. Now, let's say for instance, you would like to see all the history of the part too. So that can be done as well. In that case, what you'll have to do is go back to the Save as Mirrored Part option and uncheck this box which says Link to Original. And now when you select this mirrored plane, we'll go back and create one more, part which says Mirror 2. And now this Mirror 2 is a mirrored copy about this mirrored plane, and you now get the entire history of the part. So you have both the options. If you create a link to the original, it will make a part copy, and if you uncheck that box, it will create a mirrored part with the entire history. So this was the new command in which you can create a mirrored part inside the part environment or sheet metal environment itself. In the next example, we'll take a look at the trim tube command. So as you can see in this picture here, you have these tubes that are intersecting with the primary tube. Now we can simply use the trim tube command that is available inside the features tab. You have the command that's called as the trim tube command. But before I do that, let's go and take a look at the draft file. So in this draft file, I have my tube 1 that's 633 mm and all other tubes having different lengths. Now keep this in mind, and once I create a trim tube, this flat length of the tube should be updated as well. So go back to the original assembly and let's use the trim tube command. So the process is, so in this case, we'll create an assembly driven part feature, and the process is very easy. You select the primary tube, and the secondary tube will be all of these intersecting tubes. So I'll select 1, 2, 3 and 4 intersecting tubes, and just to have a better look, I'll align this in my left view, and as soon as I hit this green checkbox, the software creates that cut. It creates a nice cut, as you can see here, and the tubes have been trimmed really nicely. And since this is associative, once we go back to the draft file, you see that the view is out of date, and once I update this table, you'll see all the flat lengths of the tube are updated based upon the trim tube option. So this is how you can use the trim tube command inside the assembly and the draft file. Next, in this case, what we have is the base here also has some trim tubes. The base here also has some tubes that are not matching right. So in order to get that nice trim, you can go back to the trim tube. In this case, we can simply use an assembly feature and just select the tubes 1 and 2. So it creates that nice edge-to-edge connection. So similarly, you can do it for all of these tubes 1, 2, and create a cut or the connection here. So it's very easy and convenient to use this trim tube command not only to trim but also to connect the edges like this. So this is how you can use the trim tube command in the latest version of Solid Edge. Very easy way to interact with the tubes. So let's take a look at some of the other enhancements. Next one that we are going to take a look at is the enhancement in the replace part command. We now have the option to get the AI predicted solutions when you're trying to replace a part. So at any given point of time, if you would like to enable or disable the AI predicted solutions, you can go to Solid Edge options. Inside the assembly tab, you have the option here to disable or enable the AI. As of now, this AI is only available or for the planar align and axial align. Next, we have some enhancements in the assembly search options. So now when you're trying to look for a specific component, which can be a part, sheet metal, or subassembly file, inside the Pathfinder, you now have the option to use the Microsoft wildcards. So these wildcards can be used to search for a specific component, not only in the Pathfinder, but you can also do the same in parts library, inside your model view palette, feature library, symbol library, block library, and so on. So let's take a look at these commands in action. So in this in this assembly, let's say for example, if you would like to replace this bolt with a longer bolt or something else. In this case, what you can do is you can simply replace a part. Once you go to the home tab, you can simply select the part, replace a part. And now so now let's look up for the specific part. In this case, I would like to replace this part with 6552. And this is the 6552 part that I would like to replace. So once I hit open, you'll see that I get my part and it gives me a preview of where exactly the AI thinks the part will be placed. So here I have my default solution, and as the note suggests, we do not get a preview for the default solution. So let's take a look at some of the predicted solutions by AI. So this is the first one, which seems the right fit for the case. It's If we have a really good axial line and the faces touch exactly where they're supposed to. But also let's take a look at the second and third solution. So the second solution is slightly off. So this is not the right one. And let's take a look at the third one, which is completely wrong. So in this case, the first solution that was predicted by AI is right. So we can use that and hit finish. So now we have AI enabled so that we can use that to replace the part. Similarly, let's say for example, if I would like to replace this part here, I can go to replace part. And in this case, I would like to replace this with 6142 part. And for this one, I get two different solutions that are predicted by AI. Solution one, which is intersecting with the washer here, which is wrong, and solution two, which is above the washer, which is again wrong. So in this case, let's use the default solution and hit finish, which seems to be the right one. So like I said, AI, it's still a learning model, and you can now use AI to replace your part. And just to add an important note, that this AI is only available for the planar align and axial align. Next one, we'll take in this example, we'll take a look at the assembly search enhancements that have been added. So let's say for example, if you're looking for a component which has a number 67 in it. So once I search for 67, I get all the components that have the number 67 in it now. So as in this case, as you can see, SRN 716367. So this component has 67 in it. Similarly, in this one, it is 6781. It is 6781. So it gives all the components that have the number 67 in them. Now you can simply hit the cross sign to remove the previous one and type in the next part. So let's say if I'm looking for a component that has the number 63 in it. So once I do that, you'll see that the almost entire assembly is highlighted here. So now we can, so now in this, so now this is a really good example where we can use the Microsoft wildcards to narrow down our search. Now let's say, for example, if you're looking for something that starts with 63 and ends with the number 5. So we can use the wildcard, which is 63 star 5. So if we do that, our search is somewhat narrowed down. And if we expand this one here, it'll give all the solutions that start with 63 and end with 5. There's 63 and then there's 5. We have 63, 5, 63, 5. We get all the parts that start with 60 and end with 5. But you also have to be very careful when you're using this wildcard, because what it does is not only search the part number, but it also checks for the entire part name. So here, as you can see, it says 63 and there's 5 at the end. So it includes not only the numbers but also the alphabets and special numbers in here. So this is how you can use the Microsoft wildcard. So let's take a look at some other examples here. I'm looking for something that has 7 1 in them. So again, the same thing, since the naming structure of this specific assembly is SRN71, so it is going to highlight the entire assembly. So to further narrow down, I'm looking for a part that ends with number 71, but the condition here is that it has to be a number, and the numbers before that or the alphabets before that cannot be included. So I'm looking for something that ends with 71. So number 71, and hit enter. So that narrows down our search criteria, and there is only one part, that is 6371. So the hashtag sign here means that include only numbers that end with 71. So it's 6371. So this is how you can enable and use the Microsoft wildcards to search for specific components that you're looking for from the Pathfinder. Something similar can be done in the parts library as well. So let's take a look at that as well. So I'll go to parts library here. And now let's say, for example, I'm looking for a number that ends with 64. So I'll do hashtag 64. So I have two components here that end with number 64, 6364 and 6864. So like I said, this enhanced search criteria can be used not only in your Pathfinder but also your parts library. So now in this example, we'll take a look at the subtract command. So the enhancement that has been added to the subtract command is that you now can remove the disjoint bodies inside the subtract command as well. You don't have to perform one more operation to simply remove the disjoint bodies. Next, we have the option to reorder the assembly features. So this was an existing ER that and this ER had been filed by 34 different customers requesting this functionality to reorder the assembly features. So as you can see, in this case, we would like to reorder a round 1 and place it next to cutout 2. So you simply have to drag this round 1 and place it next to the cutout 2. So this functionality has been added. One more thing to make a note of is that a feature cannot be moved before the parent feature, or else it would fail. Now in the last one, we have the suppress conflicting relationships. So now it has become easier to assemble components. It's very fast and easy approach to identify and resolve a conflicting relation. So now when you're trying to place a part or reorder something, you get this resolve relationship conflict dialog box pop up, which says the current relationship has been unsolved, and in order to solve this, you can suppress one or more of these existing relationship to make it possible. So this is a really nice way and a fast and efficient way of actually placing components, reordering components inside the assembly environment. So let's take a look at all of these commands in action. So in this case, I have so here I have my first part. So in this part, this is a multi-body part in which I have a design body and multiple construction bodies intersecting with my design body. So let's go ahead and create a subtract first. So I have my target component right here, and I can select all my construction bodies one by one. And there is one more on this side. So in total I have 6 construction bodies, and you'll see that it creates a disjoint here. So now in the previous version, what I would have to do is go and perform one more operation and remove these disjoint bodies one by one. But now in 2024, you can simply go ahead and select the regions that are disjoint and let the software select it, so that you know it's selecting all the regions with a single click, and you can hit the green check box to remove all the disjoint bodies inside the subtract command itself. So now once you hide the construction bodies, you'll see that you get a nice cutout the way you expected with minimum number of clicks. So this was the new subtract command and the enhancement added to the subtract command. Next, we'll take a look at the option to reorder the assembly features. So here I have a slot that has been mirrored, and then I have a cutout. So let's go ahead and add some other features. So say for example, I would like to add a round. So round on all 4 of the edges here. And also I would like to place a chamfer on this cutout. And then one more chamfer on the slots. So for the slots, I would like to have a smaller chamfer of 1 mm. And there you go. So I have added one round and 2 different chamfers on different parts of this assembly. Now in order to reorder the specific features, you can simply select round. So in this case, I would say select round 2 and now place it below the mirror. So you see that my round now is placed just below the mirror. Similarly, the fourth chamfer, I would like to place it below the cutout one. So you can simply select it, drag and drop it next to the cutout one. So I have my slot that has been mirrored. Then I have my round 2. I have my cutout. Next to the cutout is the chamfer on the cutout. Okay. We can simply rearrange this because it looks like it's chamfer 3 and not chamfer 4. So let's rearrange that. Go to place it next to cutout 1, and there you go. So I have my cutout that is in chamfer, and then the chamfer the slots. So this is how you can simply reorder the existing assembly features inside SolidWorks 2024. And now finally we have the option. We'll take a look at the last enhancement here, the option to resolve or conflicting relationships. So let's say for example now I would like to create an axial align between these two holes, hole from this plate and the side plate here. So let's go ahead and create that relationship. I'll go axial align and select the two holes. This is going to be hole 1 and hole 2. So as soon as I select that, I get this dialog box telling me that this relationship is not possible because of the existing relationships. So I have a planar align between this part right here and the plate. Then I have an axial align between the two holes over here, and then I have a planar align between these two faces. Now In order to make this possible, we can check which relationship we would have to suppress. So let's take a look at the first one and suppress this one right here. Hit apply. Well, this relationship is not solved. So that's the wrong one. Next one, we'll take a look at the second. So let's suppress the second axial relationship. Oh, so that does actually solve the relationship and makes it possible. But the problem is, if you go and check the other hole right here, now these two holes are misaligned, which is what we have suppressed this relationship for. So that wouldn't be an ideal solution as well. The last relationship that will work is this one right here. Apply, and this actually works. At the same time, it also maintains the axial line between these two holes and these two holes right here as well. So this is how you can quickly understand which relationship is exactly conflicting or not allowing the relationship to work that you're trying to place. So now assembling components has become very easy, and things are done in a very smart fashion. Looks like I didn't save it, so let's go ahead and create that axial line one more time, and this time we know which relationship we are supposed to suppress. Suppress the last one, hit apply, OK, and save it. And our holes are aligned. Next, we'll also so this can not only be done on a regular part, but this also can be done with an adjustable part as well. So let's say, for example, if you would like to make an axial line between this screw and this hole right here, you can simply do that as well. So I'll make an axial line with the screw right here and the hole right here. So again, it will give me a conflicting relationship. So here I can either do two things, that is suppress the last three relationship, which is with respect to this specific part, and apply. But the problem is that works, but the part goes somewhere inside and starts interfering with this existing assembly right here, which is not an ideal solution. So I would unsuppress all of those and suppress the first one, so which is creating an axial line between this screw and this part right here. So I'll suppress that relationship, and you'll see that the adjustable part moves. So since we have done that, now we can create a completely or fully defined constraint here by using a face mate. So let's create a face mate between this circle right there, or that face, with this face right here. So now that is, since that is an adjustable part, it extends the length and completes that relationship with that adjustable pipe. So this is how you can use this. You can use the conflicting relationship dialog box to quickly understand which relationships are failing or not allowing you to complete the relationships that you're trying to achieve. So these were all the enhancements for 2024. I would like to thank you for attending this webinar, and I'm open to any questions that you might have.